Hey, welcome back to another tutorial for coding with Mercury. In this tutorial we continue looking at list functions, but in this case I don't want to use list functions for creating a rhythm or a melody as we have done in the previous videos, but I want to use these list functions for creating modulations for different other types of parameters. So basically every argument in functions in Mercury can be modulated with a list, which means that if I say, for example, gain 0.5, then this 0.5 could have also been a list of multiple values, so that every time the note is played, the value is changed. So this doesn't only count for gain, but also, for example, for the shape method, or for the panning method, or for many more other methods that you will find. So I want to start by adding a synth, and then we continue by adding functions to the synth that allow us to change a parameter, and then we will use lists to change those parameters in time. So let's start by making the synth and having it play a note at a 16th tempo. So the first thing that we could play with is the shape of this synth. So the shape determines the attack time and the release time, so how long will the sound be fading in and fading out. And we can change, for example, the release time with a list. So I named the list releases, so now I have to create one that is called the same name. And just to hear that it works, I will type in a few values so we can listen to the result. So now what if instead I use random, and then I create 8 random values between 20 milliseconds and 500 milliseconds. So let me print the releases, and then we can see that if I click play, we will hear a pattern emerge because of the note lengths. And this pattern will be different if I change the range and also if I create a new list. Instead of creating the releases randomly, we could, for example, also use the spread function, which allows us to go from one number to another number over a certain amount of steps in a list. So if I create 8 steps and then start at 10 and then go up to 300, then we will start at 10 and then we get equal amounts of steps in between to get to the number 300. However, to me this is a bit less interesting because it doesn't create so much a rhythmic pattern as we had with the random. So I will leave the random in there for now. So some other function we can look at is, for example, the panning function. So with pan we can move the sound to the left, or we can move the sound to the right, or in the center. Or somewhere in between. 0.5 also works, for example. So if I want to create some modulation that slowly moves the sound from left to right and then goes back to left, then I can create a list. I will call it panning. And for this we could, for example, use the spread operator. So I can say I want to spread 60 numbers and I want to go from -1 to 1. Let's print what it does. And then, of course, in the pan function, I need to add the name of that list. But you can see it doesn't work exactly how we expected, because the numbers that are in the list are only -1 or 0, while we expected some decimal values in between, like go from -1 to -0.9 to -0.8, etc. So if you go to the list functions in the documentation, you can see that some functions have a float version. So there's spread, but there's also spread float. So float, or just the letter F in this case, means that the list will output so-called floating points. And floating point numbers are numbers that are not a whole number, but are a number with a decimal. So it could be 0.1 or 0.12345. So you can see also this in the examples. So we can type spread float, or for short we can type spreadF. So let's go back to our code. And then instead of typing spread, we type spreadF. And now if I click play, we can see that the list will be filled from -1 to 1 with decimal place values. And you can also hear that it slowly goes from left to right. If I increase the length of the list, then of course it will take more time to go from left to right. Or if I go back to 16, but instead I will make this list into a so-called palindrome, which means the list goes up, but then the reverse version of this list is combined behind it. Then we will hear the sound go from left to right, but when it's at the right, it will go back to the left. We've seen how we can use a list function to generate a melody for the first argument of the note, but we are also allowed to create a list to swap the octaves. So for example, I can make a list called octaves, and then, for example, we can use the coin tosses to randomly generate 0 or 1s. And then those random 0 and 1s we can use to swap the octave notes in the instrument. And every time I click play, the random number generators will give us a bit of different results. Now this is one way to create some variety in the synth, but let's also see how we can do something similar but for a sample. So for example, I have this amen break, which is a drum beat or a drum break that we can use, and I can play it at 8 notes, so we can listen what that sounds like. It's a bit chaotic, and that is because the sample is longer than just 1/8 note. If I would set this at 1/1, then we would hear the full sample. So I can say play it at 1/8, but then maybe give it a shape of also 1/8, so it is just cut off at the right moment. But now we can, for example, create a list to change the start positions in the sample. So for example, if I start at 0.5, then it will start at half of the sound file. And 0.25 at a quarter. Or 0.75, 3/4. So something that we could do is make a list of these different positions in the sample. So I'll call it positions. 0, 0.25, 0.5, 0.75. Maybe some random part in there as well. Something at some weird location. We'll see what happens. And then we can use this list to play positions. But we can also use a list function to randomly choose some of these numbers from this list. So if we go to the documentation, you can see in the documentation under the stochastic functions, there's a method that is called choose. So choose chooses random items from a list with a uniform probability distribution. So that means if I have a list, for example, with these 3 items, head, snare, kick, and I say choose 10 of these samples, then I get a list that is 10 long with randomly chosen some of these items. So if we want to apply that in our code, I could type the choose function and then I can say choose 16 values from this list. So the list is an argument on the second place in the choose method. We can print the positions so we can see what the output is. So to wrap this up, I want to add a few effects to change the sound a little bit, and then also use a list function to change the parameters of that effect. So for example, on the saw, we can create an effect called filter, which allows us to filter the high frequency content away from the low frequency content. So if I just add the filter now and remove the other instrument, we can listen what that sounds like. So you can hear the sawtooth is more dull. But if I change the number that is behind this, the so-called cutoff frequency, then we can change at what point the higher frequencies will be cut off. So if I make a list and I call them cutoffs, then I can use a list function to generate different cutoff positions. So for example, I can use the spread function for this. And then I say, give me 5 values, start at frequency 3000 and go to 700. So I will add the cutoff's name of the list to the argument of this effect. And then we can listen to what that sounds like. So as you can hear, slowly the higher frequencies get cut off even more, and then it goes back to the beginning. We can exaggerate this a little bit by saying maybe 6200. Or maybe create a list of only 3 values. And for the drums, I want to use the gain function so we can add a bit more dynamics to the sound. So for that, I can create the dynamics randomly, list dynamics. But in this case, we have the same issue as with the spread. If I want the gain value to be, for example, 0.5, we need to have a random value that can be generated between 0 and 1. So in this case, as we can see in the documentation, also the random function has a float version. So random float or randomF. And the random float function allows us to generate floating point values randomly between 0 and 1 or between 0 and 12. So the range doesn't matter, but at least there will be a floating point value as well. So in the code, I can type list dynamics randomF, generate 8 random floating point values between 0.2 and 0.9 dynamics. And then this will be our final result. And maybe I want to double the time for the breakbeat. Okay, thank you for watching. I hope this tutorial was useful. If you want to learn more about the different list functions, then I encourage you to look at the tutorials on the bottom of the page. In chapter 4, many algorithms are discussed, different functions and how to use them with some example code as well. Also, you can find the list functions in the documentation, of course, together with all the other functions and effects and more things about the language. I'm not yet sure what the topic for the next video will be, but I will hope to see you around for that one. In the meantime, you can also join the Discord. The Discord server you can also find through the documentation if you go to welcome, and then there's a link, join the Discord community. You can ask questions there if you have them as well, or share some work that you've been making. I would be very interested to see what everybody is doing. So let me know. All right, bye.